Am I audible, students, now? Hello.
Yes,
Okay. So
yes,
due to actually I am using mobile phone today. So anyway, we want to see actually voltage division rule. And in the last session we have seen when resistors are connected in series, then voltage is divided, and when resistances are connected in parallel, that time current is divided among that parallel combination of resistors. And today we want to see voltage division rule. So means when multiple resistances are connected in series, that we know voltage is divided. But when the we want to calculate individual voltage drop across each resistance, so how we can calculate? What is the formula for that? So that we want to see. So that is called as voltage division rule. So in this circuit diagram, you can see R1 and R2. These two resistances are connected in series, and this series combination is connected across this voltage source. And when voltage is applied, that time somehow value of current is flowing through that circuit. But in this case, current flowing through R1 and R2, it is same because both the resistances are connected in series. So this applied voltage is divided across these two resistances, R1 and R2. So sometimes I want to calculate this voltage, sometimes I want to calculate V2 also. So for that, what is the formula for calculating this that voltage drop across individual resistance? And for that, there is a formula. Now on the screen, you can observe formula is written here. Voltage across any resistor means there are two resistances, three resistances are connected in series. So if you want to calculate that individual voltage drop, so how we can calculate? So formula is for that value of the resistor means which out of these three or two resistances, whose voltage drop you want to calculate, that part, that resistance value in the numerator part of this formula divided by sum of all the resistances connected in series. Means whatever values of that resistance, maybe in ohm, that value you want to add here, multiplied by total voltage of the circuit. Means applied voltage is how much, that you want to multiply. Means this is the resistance ratio and multiplied by applied voltage. So by using this formula, we are able to calculate the individual voltage drop. So here two formulas are shown here. If I want to calculate VR1 means voltage drop across this resistor number 1. So formula is R1 divided by R1 plus R2 multiplied by applied voltage. Same way, if I want to calculate voltage across this resistor number 2, so for that another formula will be resistor number 2 divided by total resistance R1 plus R2 multiplied by applied voltage. So using this, we are able to calculate the applied voltage. So for understanding purpose, so we can suppose take the value of this resistor, say 2 ohm, okay, and the value of this R2 is say 3 ohm, and applied voltage is say 10 volt. Okay, so these are the values given in this circuit. So can someone please, not someone, all of you want to calculate the voltage across what is the value of V1 and V2? You want to calculate this. So I am waiting for here 1 minute. So you want to write your answers in chat box, or you can unmute yourself and directly tell me what will be the V1 and V2. I got some message in chat box. 4 volt. Piyush is saying 4 volt, but it is 4 and 6 volt. Okay, means it is 4 plus 6, 10. Okay, so we will check this whether it is correct or wrong. Other also try to solve this. I got only one answer. Okay, again Piyush is saying VR1 is 4 volt and VR2 is 6 volt. Okay, so it's a very simple calculation. Again, someone replied. Just I want to check this. Only Piyush is sending answers. Others are just ideally sitting here. Anyway, we want to cross verify this. So VR1, for calculation of VR1, formula is R1 divided by R1 plus R2. So value of R1 is 2 divided by 2 plus 3, 5 multiplied by 10. I want to calculate this. 2 by 5, 0.4 multiplied by 10. So answer is here 4 volt. Then for another value of that R2 is 3 ohm, 3 divided by 5 multiplied by 10. So same way again we can calculate 3 divided by 5 multiplied by 10. So this is a very simple numerical, not much very complicated here. So what will happen? This applied voltage is divided among these two resistors, and for cross verification, what we can do? Simply we can add this 6 plus 4, that is 10. Means that 10 volt is divided across these two resistances. So this is a very simple numerical. Maybe in some of the numerical circuit is slightly complicated. So I want to show one some complicated circuit. Suppose this is 3 ohm, this is 2 ohm, this also 2 ohm. This will be 10 volt, positive, negative. So this is the circuit here, and I want to calculate voltage. Suppose I can say this is R1. I want to calculate VR1. Okay, this I want to calculate. VR1 I want to calculate. So can someone explain me how to solve this kind of numerical? I am waiting for your answers. You can unmute yourself and just try to answer. No one is able to solve this kind of numerical. This is not much complicated. So anyway, I want to explain this thing, how we can solve this. So in this circuit, what is happening? This 2 ohm resistor and another 2 ohm resistor. These two resistances are in parallel. So very first, you want to calculate the equivalent resistance of this 2 and 2. So what will be the value of equivalent resistor here? So for that, you know formula for calculation. 1 upon R equivalent. 1 upon R equivalent is equal to 1 upon, suppose this is R2 and this is R3. 1 upon R2 plus 1 upon R3. This is the formula. This thing we have seen in the last session. So therefore, R equivalent is equal to R2 multiplied by R3 divided by R2 plus R3. This will be the formula. Okay. So here 2 into 2 divided by 2 plus 2, that is equal to 4 by 4, that is equal to 1. Okay. So this will be the equivalent resistance here. Now this equivalent resistance and this resistance, these two resistances are in series. Now you can apply here voltage division rule. So if you want to calculate VR1, so for that, what will be the formula? Now you want to calculate voltage drop across this 3 ohm resistance. So that resistance is in numerator. So formula is R1 divided by R equivalent plus R1 multiplied by applied voltage. Applied voltage is, you can denote it V only. Okay. So according to formula, 3 divided by 4 multiplied by 10. Now you want to calculate this. Okay. So 3 divided by 4 is equal to, I got this 0.75 multiplied by 10. That is equal to 7.5 volt. So answer is 7.5 volt. Okay. So in this way, you can solve this kind of numerical. So hope everybody understood this. Okay. Before that, I want to check chat box. I think someone has. Okay. Piyush has replied 30. What is 30, Piyush? Hello, Piyush. Am I audible? Okay, you assume 40 volt. Okay,
Yes.
that's why.
Yes, sir.
Okay, okay, thank you. Okay, it was not visible. That's why you have assumed. Okay, thank you. So anyway, hope everybody understood up to this point how to solve this kind of numericals. Now we want to see actually the current division rule again. Okay, so I want to share the next page. Okay, so this is current division rule. So normally when resistances are connected in parallel, so that time current is divided. Okay, so this is I1 and this I1 is divided here in two branches, I1 and I2. So if I were to calculate this individual current, I1 or I2, so how I can calculate this? So for that, there is also again one formula for calculation of this. And what will be that formula that you want to understand? Before that, in some of the numerical, what is happening? This applied voltage is given, only resistance values are also given, and you want to calculate either I1 or I2. So in that case, what you want to do, very first, you want to calculate the equivalent value of these resistances, okay, and so that you can calculate the total current. Okay, once you can calculate this total current, then you can apply current division rule if it is not mentioned. But in some of the numerical, this I1 I value is already given. If it is given, then you can easily directly apply the current division rule. So this thing is important for this kind of numericals. So let's understand this formula first. Okay, just I want. Hope my screen is visible again now. Current through any parallel branch. So it may be I1 or I2. We want to that individual current. So what will be the formula? Resistance of the opposite branch. What is it mean that you want to here? You see, if I want to calculate current flowing through resistance, I want to the opposite resistance of this branch. If you want to calculate what, then in the numerator you want to take okay, that is the formula. That is the meaning of this resistance of opposite branch divided by all the resistances. Whether these resistances are connected in parallel, then also you want to simply add this. No need to calculate what will be the equivalent resistance here. Okay, it's important. Of all the resistance multiplied by total current. Okay, means you need to multiply is how much. Okay, so in some of the numerical, this total current is already given, but in some of the cases it's not given. Only voltage is given and this resistance values are given. If resistance very first you want to find the equivalent value of this resistance, and then you are able to calculate the total current. Okay, once you are able to calculate total current, then you can calculate the individual current flowing through that resistance. Okay, so this will be the formula. So hope everybody understood. Or if you have doubt, you can ask me again. Okay, no one is having doubt because this is not complete. So in this, suppose applied current is 10 ampere. Okay, this resistance value is say 2 ohm. This will be suppose 3 ohm. Okay, I want to calculate current flowing through I2. Resistor number 2, which is denoted here I2. So I want to calculate I2. I2 I want to calculate. So what will be the formula for that? Resistance of the opposite branch. So what is the opposite branch resistance here? It is 2 ohm. Okay. So I am taking here 2 numerator division of all the resistance. Here actually these two resistances are connected in parallel. But what according to formula we want to simply add this 2 plus 3. So this will be the resistance ratio multiplied by applied or multiplied by total in this numerical total current is already given. It is 10 ampere. Okay, so I will to write this 10 ampere here. Okay, now I want to calculate the current. So please add this and write the answer in chat box. I am waiting for your answers. So, student, okay, so I am going to solve 2 divided by 5. It is 0.4 multiplied by 10 ampere. So it is 4 ampere. So I got here answer, it is 4 ampere. So is it correct, student? Okay, now you have to calculate again I1. What is the value of I1? So please try this. So this numerical is in front of me. So just hold on. I want to hold this camera. Now you want to calculate this I1 is equal to how much? So I'm waiting for your answer, students. Am I audible, students?
Yes, sir.
Okay. So please try calculate this fast and let me know or write your answer in chat box. No one is replying here. Why? See, student, already we have calculated current flowing through resistor number 2, and we have got this answer. It is 4 ampere. So definitely here only 2 resistances are connected in parallel. Means remaining current is flowing through this resistor number 1. Means if you take the difference 10 minus 4, so that will be the also correct answer. So here answer is 6 ampere. No need to use calculator also. Is it clear, everyone?
Yes,
So,
sir.
okay. Anyway, we will stop here for today's session. And in the next class, we will see when multiple capacitance are connected in series or in parallel. So how to calculate equivalent capacitance or equivalent of that whole network. Okay.
Excuse
we
me,
will-
sir.
Yes.
Sir, in I1,
What I want? Hello. You are not audible.
R2.
Hello. 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 Someone want to ask anything, but your voice is not coming. Hello, students. Am I audible, students?
Sir, I'm asking that in I1, will there be R1 upon R1 plus R2 or this only?
No, opposite resistance.
Okay, sir.
If you want to calculate I1, you want to take the opposite resistance, means 3 divided by 5
So,
multiplied
sir,
by.
I1 would be 6.
Yes, that is correct, because already we have calculated current flowing through R2 is 4 ampere, means remaining current is flowing through R1. So you can take 10 minus 4 also, you can take, you will get the difference is 6 ampere.
Okay, sir. Thank you.
Okay, thank you. So again, anybody is having any doubt? If you have doubt, you can ask me. Otherwise, later on also you can write in my WhatsApp number. So anyway, I will solve your queries also later on also. Okay. So CR, please check who is absent. Please send these numbers on my WhatsApp number, please, Tushar.
Okay, sir.
Okay. Are you sent this number? Okay, so we will stop here for today's session. Now you can leave the session. Otherwise, I will end the meeting within 1 minute. Hello, Tushar. Already I have sent that numbers on your WhatsApp. Please verify this. If it is correct, then no need to send a message. Okay. Okay. I am ending this meeting.